Hello and welcome to my new playlist, Python Concepts. Here we'll try to learn very basic concepts of Python so that we can utilize these concepts into solving real-world coding problems. So the objective is to learn basic Python programming, and at the end we'll be able to solve practical problems, practical programming problems by using this particular language. And if you are much into solving problems rather than learning concepts, you can also explore the other playlist in my channel, Python Drills. But I'd suggest you to make very clear concepts before you dive into solving the codes, or writing the codes and solving the problems. So the topics that we'll cover will be practically everything that you need to know, which are must-knows in order to do efficient coding in Python. So we'll start with data types and variables and lists, and we will also put some emphasis on statements, and we'll also learn dictionaries and loops, functions, and object-oriented programming, including classes, files and exceptions, advanced topics. We'll also spend some time on learning how to write clean codes so that it's understandable by other people. And at the end of this course, we'll also learn how to utilize our coding skill by doing some real-world yet small projects. So the topics on which I will give more emphasis are in bold here: the statements, loops, functions, classes, and utilizations, so that you know which things are to be used for most of the times. There are tons of online and offline documentations for learning Python, but you should at least one or two good textbooks, one or two beginner level textbooks at your disposal so that you can learn efficiently and quickly, and which do not go into too many sophisticated details so that you get frustrated. One of the most fundamental and good books would be Eric Mathis' Python Crash Course. Also, feel free to explore all the other materials that are available. As a platform, due to its versatility, I will use Jupyter Notebook that you can easily install through Anaconda 3. Just make a Google search, Anaconda 3, and you'll be able to install Jupyter Notebook, in which you can write and debug your codes. But any other text editor or compiler will do, as long as you are able to run the code after installing Python environment in your machine. In order to utilize this course efficiently, you should categorize the problem, which topic it belongs to. You should recognize that. And if you are stuck or lost, you should go through the documentation, meaning Python manual, or the reference you are using, the textbook. And to get your hands on that, you should solve 2 to 5 problems on your own on the topic. Start from the simple and dive deeper and longer codes. And also, you should try to solve problems that utilize multiple topics, for example, statements and functions in the same code, so that you can get used to implementation of your concepts. And at the end, you should target to make a real-world, practical, yet small project, so that your learning is actually being utilized. So that's all the setup for this course. Let's start learning Python. I will see you in the first lecture in the next video. Thanks. Hello and welcome to the Python Concepts Lecture 2. Here we will learn how to use Jupyter Notebook to write Python codes, and we will learn how to define variables too. So it's the very fundamental and basic lecture when you are just beginning to learn Python and running your preliminary codes. So this is the environment that you will see when you run Jupyter Notebook for the first time. And you can see that it's kind of a word processor, and you can just click the plus button to make more code blocks where you can write blocks of codes. And there are other common buttons like save, so that you can save your codes. And when you see the screen for the first time, you just click new Python 3 so that you can get to this point. And you can run your blocks of code by clicking just run or pressing Control Enter. And so let's say if you are in your first block of code and you were trying to run the very common and conventional hello world code for the first time. So the first thing is to keep your code clean, so you can make a lot of comments so that it's understandable by other readers. For example, here, if you use the hash hash before your line of code, then it becomes a comment, so it won't affect any of the running of your codes. But if you remove this, it becomes a code. So make sure you use the hash before any of the comments you make. For example, this Python concepts lecture 2 using Jupyter Notebook and variables. That is that is the first comment that I'm using here, so that you know what I'm going to write. So to get an output hello world, you can just use the print command and press Control Enter so that it shows as an output hello world. You can also edit this. Hello Python world, it will change it accordingly. And let's say your name is X, then it will become hello X world. So this is kind of the very basic way to run a code in Jupyter Notebook. You can use other text editor like Sublime Text or Notepad++ to write your code, so that you can get the good indentations and the highlighting and different colorings, so that you can understand easily where your code is going, or whether there's a problem or not. And also, there's another way to define variables instead of just using the print command to get an output of your program. You can define it. For example, this string, hello world, you can define it and give it a name like message. And after that, you can just say print message, and you will get the same output. Just to make it more obvious, I can remove the world and it will just print hello. So this is how you have just defined your first variable, and you can check the type of your variable. You can see that it's showing str, which means it's a string, and there are also various other types of variables like integers or floating points. For example, you can define pi as 3.14, and you can just print pi. So you can see that it's printing both message and also printing pi. And you can also check the type of pi. It's a floating point number. If it were an integer, for example, it was only 3, then you can, if you check for the type, it will show an integer. So this is how we can define various types of variables. And one disclaimer is that try not to use the predefined keywords in Python. For example, don't use any conditionals as the name. If or for, see, when I'm writing it right away, it's becoming bold, so so that you can know that these are the keywords, and you should not use them as names of your variables. So this is one disclaimer and a very important thing that I had to mention about variables. So in the next lecture, we will try to dig deeper into other data structure and variable types. Hello and welcome to the third lecture of Python concepts. Here we'll discuss on variables and data types such as strings and numbers. In the previous lecture, we have actually introduced the concept of variables, how to define variables and how to check the types of the variables. And we have introduced our first hello world print statement and written our first code. So it was kind of an unorganized introduction. And this lecture is dedicated to variables and data types in an organized way. So just let's get to kind of a flashback. We have written our first hello world code with the print statement, and we have learned how to define a string type variable and name it like message and then print it. And also we have explored how the other types of variables can be. For example, we have defined integers and we have defined floating point numbers. And we have also given a disclaimer like we should avoid obvious errors by avoiding using keywords like for, if, or div, such kind of keywords which are actually used in Python. And these are some outputs of our preliminary codes. So there are several types of data, and we can define different types of variables. One very popular type of variables is strings, which are actually characters, and we can define those as in one quote, or in single quotes or double quotes, whatever it is, and Python will recognize it as a string. For example, here we have defined a string called myString, where these characters, some characters, including the white space, is included. And we have shown how myString is by using the print statement, and it's showing some characters. And there are several methods that you can apply to strings or other types of variables. For example, here we have actually named a string as my name, and its first last, you can see that the first character of each word is capitalized. And we can apply several methods. For example, upper method, which converts all the characters in the string to upper letters, capitalized letters. And we can also apply lower methods. For example, if we use a print statement, and inside the print statement, if we use my name dot lower, then it will actually convert all the letters into small letters. So these are some kind of popular usage of different methods on strings. Now let's come to concatenating strings, which is also a very popular usage of methods on strings. For example, we have defined John as first name and Smith as last name. So the full name you can imagine as John Smith. So in order to print the full name, we have to use full name is equal to first name plus last name. And if we print the full name, then it will actually concatenate the two strings with each other. And you can see that it has actually printed John Smith, but there is no space here. So in order to incorporate the space, we can actually use this. We can actually include a space inside that and define it as full name. Now we can see that this the white space is between the first name and last name. And the last thing I would like to highlight on strings is how to avoid syntax errors. You can see that whatever it is inside of a single quote or double quote is considered a string. But what if it contains an apostrophe? Sometimes it will create a trouble, sometimes it will not. If you define the string as inside a double quote, it will not create any problem. For example, here it has actually printed my name's James Bond with the apostrophe. But if you had used a single quote, then Python would not recognize it because when the apostrophe occurred, it would think that the string ends here. So if you run this code, it would say an error, invalid syntax. So you can see that the syntax errors or other kind of errors in Python are kind of self-explanatory. So in this occurrence, you can avoid this kind of occurrences by using double quotes so that you can actually use the apostrophe inside your string. And another type of data is integers. You can see that you can do the addition, subtraction, multiplication, or division just as you do in a calculator, and it will show the output. For example, 1 + 1 is equal to 2, or you can define something as you have done for the strings. For example, result is equal to 3, and we can actually print the result. So we can see that this is 3, and we can also see the type of result that is int. So it's an integer. And same goes for floats, the floating point numbers. You can do same kind of addition, subtraction, multiplication, and division as you have done for integers. And it will approximate according to what is defined for floating numbers. And the last thing I'd like to highlight here is how to avoid typing errors when you're using different types of variables. For example, you have defined an integer called age, which is 10, and you have defined a string called greeting, and happy birthday, your age, something like that. So let's say you want to send a greeting to someone who has just turned 10 years old, and you would like to print this greeting. So if you use the concatenation of the strings, you can see that there's an error, and in this error, it is a type error, and it is showing that you can only concatenate string, not integer to string. The error is occurring because you are trying to incorporate an integer inside a string. You are trying to mix up numbers with a string, so it is not allowing something like that. In order to avoid this, what you can do is that after greeting plus age, you can actually convert this integer into a string by defining it as a string. And after that, you can say, you can see that it's actually printing what you have intended to. Happy birthday, you are age 10. Now this 10 is not an integer. It has actually converted this age variable into a string and then concatenated it after the greeting string. So as a whole, you have been able to print the whole sentence. So that's what I had to share about the different kinds of variables and data types like strings and numbers. And the next lecture would be on lists. See you there. Hello and welcome to the fourth lecture of Python concepts. Today we'll learn lists and indexing, a very important part of Python coding. A list is a collection of items that could be anything, characters or numbers or something else that is in a particular order, which means that when you make a list, the elements have a particular position, or in other words, in Python terminology, they all have, each of them has an index. For example, when we define an array or a list called myArray, it has 4 elements here, 0, 1, 22, and 33. So it has 4 positions, first position, second position, third position, and fourth position. But in Python, the indexing starts at 0. So the first element is at index 0. Then the second element is at index 1, and so on and so forth. And here I have another list called dogs. Here I have two kinds of dogs in my list. One is retriever, another one is husky. When your items have characters, you have to put them in single quote. And then when we are printing my array, it's showing 0, 1, 22, and 33. And when I'm printing the dogs, it's printing retriever and husky. Now, if I want to access my array, and I would like to access with the index position. So if I access it by position 0, my array 0 would be the first position of the first index of the list. So it will show 0. On the other hand, if I would like to access the third element, it will be index 0, index 1, and index 2. So I would have to access the index 2 and it will show 22. And that's how we can access the elements of an array by the indexing. And also we can use the characters. For example, if we would like to print my first dog was a retriever or a husky, we can actually first print this portion, a string, and then we can access the index of my dogs list. For example, I'm accessing dogs 0, that is the first element, that is a retriever, so it's showing the dog is a retriever. If I were to access the second element, it would show a husky. And also we can actually modify the elements of a list by indexing. For example, first I'm printing my array, so it's showing 0, 1, 22, and 33. But if I access the third index, that is the fourth element, and make it 222 instead of 33, and then print it again, then I will see that the fourth element, that is the third index, has been changed. From 33, it has become 222. That's how I can change a particular element by accessing a particular index. And also we can apply several methods on a list, like we can add an element, we can delete an element, or we can modify elements. For example, I have a collection of my toys, like I have a dog, I have a cat, I have a bunny, and then I have printed my collection. It's showing dog, cat, and bunny. But if I apply the append method, a car, it will add an element, it will add another toy at the end of my list. So if I print my collection again, then it will show that beside my previous list of toys, it has added another toy called a car. So that's how we can add an element to a list. And we can also, we don't have to just add to the end of my list, we can add it anywhere. For that, we can actually use the indexing again. For example, let's say we want something to be added at the beginning of my list, so we have to use the insert method. So we'll say my collection. We'll say my collection dot insert and the index and whatever I would like to insert. For example, let's say at the beginning I would like to insert a bike. So I will say dot insert 0. That means at 0 index, that is at the first position, I'd like to insert bike. Then when I have printed my collection again, it will show that at the first position there is a bike. We can also use anything else. For example, let's say in the second position, I'd like to use a ball. And then if we print, it will show that at the second position there is a ball. And we can also delete anything by indexing. So we have to use the del function. And from the after the del keyword, we will use my collection at 1 index. So from the second position, it will have been deleted. So the second position is the ball. So after printing, it will show that the second position, the ball, is no longer here. So we'll see only bike, cat, bunny, and car. And also there is a very popular method called the pop method to delete elements from a list. So for that, we'll use, let's say I have 3 scores, 10, 20, and 30. And let's say I have printed my scores, 10, 20, and 30. And If I use the pop method, myscores.pop, then it will just pop the last element from my list. So if after applying the pop method, if I use the print myscores again, it will show only the first two elements and the last one will be popped. And also we can pop any element as we want. For example, if we access the first element and use the pop method on it, then it will pop that particular element. For example, now after popping the last element, I have these scores in my hand, 10 and 20. If I use myscores.pop at index 0, that is the first position, it will pop out this first element. And after I print my scores, it will show only 20. And also we can access the elements by value. Let's say I have 3 scores called my scores, a list which has elements good, very good, and bad. So if I print my scores, it will show good, very good, and bad. But let's say I want to remove the bad element and I would like to only show the good and very good. So I will use the .remove method. So my scores.remove bad. So I'm accessing this particular element, bad. So it will show, then if I print my scores again, it will show only good and very good, and it will remove this particular bad element. In a similar way, we can remove any other element I want. Then a very important aspect of sorting is that my letters DAG. Sorting is organizing the elements of a list in a particular order. So here you can say that there is no order in these elements. But if I use .sort method on this particular list of elements, it will actually alphabetically sort them. For example, at first, my letters would show the original list, DAG, but after I use the sort method, it will actually sort them alphabetically, A, D, and J. And a very important and popular method is reverse, just to reverse the orders of the elements in a list. So let's say I have print my letters, we have JDA, and if I use .reverse method on it, then it will actually reverse the order of the elements. So the A will be at the first position, D will remain at the second position, and J will be at the last position. So if you want to reverse the order of your elements, you can use this reverse method. There are also tons of other methods associated with lists, and we'll possibly not learn them today, but this is kind of a basic introduction to the lists so that you can use the indexing and also add or remove elements and modify elements in a list. So in the next lecture, we'll learn more things about lists and work several methods on lists. See you there. Hello and welcome to the 5th lecture of Python concepts for loop. Just a flashback of the previous lecture, we have learned about lists and indexing, and we have learned how to use indexing to modify, delete, add or subtract any element from a list and how to work on a list. So after that, we can actually do more by using for loop. Many times you have an array or a collection of numbers or characters or strings, and you want to do the same operation on every element. Instead of doing that manually, you can use the utility of for loop, meaning that you can use a loop, you can define a loop, and you can go through every element or a particular set of elements in your database, and then you can do a particular operation on each element. So that's what is actually done with for loop. Let's start with an initial, a very preliminary level of example. For example, I have a database of salaries in my institution. For example, there are 3 employees whose salaries are $100, $200, and $1,000. So let's say in the new year, I'd like to see what happens if I double each of their salaries. So I run a for loop, let's say for salary in my database, when I define that for loop, it will actually go through with each salary. It will go through each salary, and then I will print salary times 2. So I will double this variable by number 2. And then after I print that, you can see that the salaries are doubled. 100 becomes 200, and then it goes to the next element. 200 becomes 400, and then it goes to the next element, 1000, and it becomes 2000. So just a disclaimer, this salary is actually arbitrary variable. It can be anything you want. For example, you can make it I. So you have to change it here also, and it remains the same. So let's come to the second example. What can we do? What other things we can do with for loops? Let's say we have 3 students in our class: student A, student B, and student C. So I will run a for loop through each student's name and send a greeting card in New Year. So I will run a for loop for student in students, and I will print Happy New Year. I will use string concatenation, and as these are characters, there will be no errors. So I will use Happy New Year and then plus and then student. So it will go, it will use this variable and it will go through each element of this student's list. So at first it will use the first name of the student here. So it will print Happy New Year A, and then it will go to the second student's name, student B. It will print Happy New Year, the second student name, student B, and then it will print the same for the third student. It will go on and on until it reaches the end of the list. And we can also introduce the concept of range here. Range means you can run a for loop or you can run a conditional for a range. When you run a loop through a range 1 to 10, one thing you have to consider that in Python, the lower limit is included, but the upper limit is not. So it will start at 1, but the upper limit, it will not go to 10. It will stop at 9, just the previous element. So when you print the range of numbers from 1 to 10, it will print from 1 to 9. If you print from 1 to 5, it will print 1 to 4. And also one thing you have to consider that Python is indentation sensitive. So after a for loop, after this colon, you can see that this the next line is kind of indented. So if you do not use this indentation, you will get an error. So always make sure that you are using the proper indentation. In Jupyter Notebook, it automatically sets the indentation, so you don't have to worry about that. And this is also kind of helpful because you can know that this line is under the block of the for loop. And also you can use the range utility inside a list. For example, you want to make a list of numbers from 1 to 4. So you can make a range of 1 to 5, and then you can make a list of them. And if you now print the numbers, you can see that there is a list containing 1, 2, 3, and 4. If you make it 1 to 11, you can see 1 through 10. Now, let's say what we can do inside a for loop. Let's say you have 9 employees whose salaries are 1 through 9, and now in the new year you want to double their salaries. So what you can do is that you can run a for loop for salary in range 1 to 10, and then you can set, you can define a new variable, new salary is equal to salary times 2. So each of the salary in this range will be doubled. And then what you can do is that in this empty new salary database, you can use the append utility to deposit the new salary values. So you can see that after you print the new salary database, you can see that all the numbers in the range has been doubled. So without doing manually doubling all the salaries, you can actually go through this range and you can double all the values, and you can actually collect those values in a newly defined database. And also here is another small example, like how you can use the indexing to show, let's say you want to see just the first two elements. So you can actually use the indexing for, let's say in the new salary database, you want to see only the first two elements. So you can use the indexing 0 to 2. Just to mention that the upper bound is not included. So you will see the index 0 and index 1. That means the first and second element of your new salary database. So if you print it, then you can see only 2 and 4. Just to mention that from 0, if you start from the beginning, if you start from the indexing 0, you don't have to mention 0. You can just write here colon 2. So it will understand that you are starting from the beginning and you will go to the second index, and it will print the same. If you want to print the first four elements, then you can write from the beginning to 5. Then you can see that index 0, index 1, index 2, index 3, index 4. So you can print up until index 4. So you have to write here from the beginning to index 5, from the beginning to 5. And you can also do these things in case of characters. Let's say you have a collection of players A, B, C, D, and E, and you want to send the best players to your, you just want to show your best players so that they can play. The others will be excluded. So you can run a for loop through these players, and you can only select an indexing for from the beginning to 2. That means you are selecting from index 0 and 1 and excluding the upper bound 2. So it will print just the first A and B players. Let's say you have selected just these first 2 players here. You can also do 1, 2, 3. So that means that you will start from index 1, and you will go up until index 2. That means you will go to, this is index 0, this is index 1 and index 2. So it will print B and C here. Let's see if it works. Yes, it shows B and C. So that's how you can select a particular portion of a list by using indexing in the for loop. The last thing here is the concept of tuples. You can see that the elements, the values of lists can easily be manipulated, they can be changed, but sometimes you want the facility that the values cannot be changed. So that's how the concepts of tuple occurs. In tuples, you define them by parentheses instead of this third bracket. If you define a list with this first bracket, their values cannot be changed, and this collection of numbers or characters will be called a tuple. So if you print a tuple, you can see that this will not be shown as a list, but as a tuple. You can recognize them by the first bracket. And let's see what happens if I want to redefine any particular element in a tuple. Let's say I want to change the first index, that is the first element 2, and I want to assign the value of 100. And if I run this, it will show an error, and it shows that tuple object does not support item assignment. If you want to change the value, you have to define the entire tuple. So that's one of the facilities that you want to use time and time. So that's what I had to share about the for loop, which facilitates doing a lot of works, and you can reduce tons of workload by efficiently using for loop. So the next lecture will be on if statement and conditionals. See you there. Hello and welcome to the 6th lecture of Python concepts, if statement or conditionals. Here we'll learn how to use conditionals, that is, print something or do something if something is true or false. That is, based on a given condition, we'll do something, and if it does not satisfy the condition, we'll do something else. So for that, we use if statement. Now, flashback that in the previous lecture, we have learned for loop. That is, we have learned how to do repetitively similar things to every element in a list, or modify or delete or add something according to our need while inside a loop, so that we can automate the things instead of doing manually. So this is a simple block of code for introduction to if statement. In a lot of the countries, it is permitted to vote only if you are more than 18 years of old. So let's say we have a variable called age, which is 17. So we can make an if, elif, else block to check whether a person is permitted to vote. So we have original block. The first block is an if block. If the age is greater than 18, we will print that he or she is permitted to vote. Or if the age range is greater than 16 or but smaller than 18, will print almost there. That is, he or she is not eligible to vote yet, but he or she will be soon. Else, the number will be too small, so we'll print too young. So when we run this loop, it prints almost there because our age is 17. If we give an age of 20 that is greater than 18, it will print permitted to vote. Or if we print something very small, like age, 5 years of age, then it will print too young. So that's how we can use a block of if, elif, else blocks. That is how we can use conditionals to print something or do something according to our need. And a lot of the times we can use if statements inside a for loop. So that, let's say we have a set of results, the number of points that students have scored in a particular exam. Let's say some has got 33 points, some has got 66, some has got 50, some has a perfect score, some has got 80. And we would like to know how many students have passed, and we would like to report the number of passed students. So we'll write a for loop for point in results. So in order to count how many students have passed, we will define a variable called count, and it will start at 0. And to deposit the number of passed students, we will define an empty string first called passed, where we will actually collect the numbers of the students who have passed. So for point in results, inside that for loop, we will define an if statement. So let's say our threshold points for passing is 50. If someone scores more than 50, he or she has passed, otherwise he or she will fail. So if the point is greater than 50, we will actually count the number of passed students, that is count equal to count plus 1. So the count is no longer 0, it will be 1. And then in the passed list, the empty list, we will actually append that point that has actually passed. So what is happening is that we will go through each of the points in this results list, and we will find out whether it's greater than 50 or not. If it's not greater than 50, we'll do nothing. We'll go to the next element. If it's greater than 50, we'll count plus 1, and we will deposit that number in the passed list. So this will go on for the last element, so that we go through every point, and then at the end we'll print the number of counts, how many students have passed, and we'll also have print the passed, this list where the number of passed students have actually accumulated. So if we run this, it's showing that 3, that is number of passed students is 3, and which students have passed. These numbers are actually collected in the passed list. So just to make it more obvious, let's say we have added another student who has scored 15, and another student who has scored 95. So if we run it again, you can see that past students has increased to 4, and also this 95 is collected here. And the concept of Boolean is very relevant here. Sometimes we want to know if something is true or false. So let's say we have a variable called car. I have 8 cars, and if I want to check, I should check it against the value. Let's say if I write car equals 8, then it will check the value of the car against this number 8. And as the predefined value of car is 8, it will return true. If it's not, then it will return false. So that's how we can actually check Boolean statements. I have introduced this concept here because it will come in handy. And we can actually check conditionals without writing any if statement or for loop. Let's say I have a number, an arbitrary number 28, and if we want to check whether it's even or not, so we can actually check it against the definition of even number. That is, if we divide it by 2, it's called mod operator, and the remainder is equal to 0, that means it's an even number. So as this is 28, obviously it will return true. Just to make it more obvious, let's try it against 3. Then it's returning false, because when we divide it with 2, it will not have a remainder of 0. So that's why it's an odd number, and it will return false. So that's how we can actually check Boolean statements. And the last block of code we will see today is checking a list. Let's say we have a list of banned users. Let's say I'm an internet provider and I have a list of banned users who have done some bad things, so I have banned them so that they cannot use my bandwidth or internet service. So I have actually collected them in this list, A, B, C, and X. And let's say I have a new user who has not yet been banned. So I have defined it in Y. So I can check with an if statement whether this element is in a banned list or not, so that I can actually exclude this user and permit him or her to use my service. For example, if I say if user, that is this list, is not in banned users, this is kind of an intuitive syntax that you can use in Python. Is not in banned users mean whether it will check throughout this list, and if it does not find this element in the banned list, it will print something that you are not banned. So that's how we can use an if statement to see whether a particular element is in a list or not. So that's what I had to share about if statement. The next lecture will be on a very particular type of attributes in Python called dictionaries, which has so many facilities and utilities, which we'll discuss in detail. Thank you for joining this lecture. I will see you in the next. Hello and welcome to the 7th lecture of Python Concepts, Dictionaries. Here we'll learn how to associate related values like salary values with the employees' names in a database. Flashback from the previous lecture is that we have learned about the if statement, that is how to use conditionals and how to use for loop in association with a nested if loop, if conditional. So if you have got a good grasp about for and if loop, this lecture will be really easy. So a dictionary is kind of a collection of associated elements. Let's say you are an employer and you have a database of employee names. And when you click on someone's name, you want to see the associated salaries. So the syntax to make a dictionary to facilitate this purpose is that you make a pair of keywords, let's say the name, and with that keyword there will be an associated value like the salary. So the syntax for a dictionary is a keyword colon a value. or let's say more simplistically, it's name colon salary. So preliminary at preliminary level, we have a salary database. Let's say we have 3 employees, A, B, and C, and their salaries are 100, 200, and 300. To make the database, you have defined a dictionary called salary. And in this dictionary, you have actually, in the second bracket, you have defined the pairs, the keyword and value pairs. And when you print this a specific salary, you call them by index. And by index, you don't do that by the general indexing scheme of Python. Rather, you just have to call them by the keyword. Let's say you call the salary with the keyword A, and it will show the corresponding salary. If you call it by salary B, then it will show the corresponding salary 200, and so on and so forth. And if you want to add any information to the database, you don't have to redefine the dictionary or anything. You just have to define a new element by defining a new index, let's say D, and give a corresponding value, let's say 500. And if you print the entire dictionary, you can see that the value D, the keyword D is added with associated value 500. And there are other facilities that you can actually do with the dictionaries. Let's say you have a list of participants in a poll and they have responded which cars are their favorite. Let's say I have collected this information in a dictionary called favorite cars, and participant A has responded Lamborghini, participant B has responded Ferrari, participant C has responded Nissan, and that's and at the end you want to print whose favorite car is what. So you print A's favorite car is, and then you call the corresponding dictionary value by the keyword. So when you print this, you can see that A's favorite car is Lambo. So that's how you are using string concatenation to call a particular element in a dictionary. You can also call any other value. So you just have to change the keyword, and you can see that C's favorite car is Nissan according to the poll information. And also we can use the previous concepts that we have learned in the previous lectures, like looping and conditionals. For example, you can loop through the elements in a dictionary. So for that, the syntax will be a little bit different in a for loop. In a for loop, you will have to say, you'll have to give 2 arguments. One is the key and another one is the value. And let's say you want to loop through the favorite cars dictionary. So you have to loop through the key and value in favorite cars.items. You were applying the items method here. And just to print a pair of key and the value, then you want to print the key, and then you want to print the value. If you run this loop, then you will see that every key and every value is printed. Another one is that you want to use possibly for loop and a conditional in combination. So let's say we have a favorite cars dictionary with keywords and value pairs, like A with Lambo, B with Ferrari, C with Nissan, D with Honda. And we want to see whether 2 particular participants are here. So we want to apply a conditional. Let's say we make a separate list named friends A and B, and we run a for loop for name in favorite cars.keys. So you want to go through the keys in these favorite cars. So you want to go through A, B, C, and D. And when you go through that, you check whether these keywords match with these friends. So if you get a match, you just print hi name, your favorite car is, then you call the name. So you can see that only 2 friends are in this list. So it will print 2 lines of code. Hi A, your favorite car is Lambo. Hi B, your favorite car is Ferrari. So that's how you can use looping and conditionals. And there are so much more utilities in dictionaries, as this is a very preliminary level of introduction to dictionaries. I would like to not go into too many details, but you can do more sophisticated tasks in dictionaries, like you can include a list in a dictionary, or you can define a dictionary inside a dictionary. But this will become too much complicated if you do not do it in a clean or a slick way. So my suggestion is that you should not go too much deep into dictionaries. Rather, you should try simpler methods like using lists or using for loop and if statements with a simple list, rather than going into dictionaries if absolutely not necessary. So that's what I had to share about dictionaries. The next lecture will be on while loop and other associated contents. Stay tuned. Hello and welcome to the 8th lecture of Python concepts, while loop, break, and continue. So these are 3 important concepts in coding where you have to use conditions, or you want to run a loop, or you want to get out of a loop based on some given conditions, which you will run into very frequently. So first, we have to be habituated or introduced with some other concepts so that you can use them in your codes. The first concept I'd like to introduce is printing a user input. Sometimes, let's say, in many times you see a prompt on a display screen and you click on some button and it does something according to your response. For example, let's say I have put it here, input, enter a number to print it. So, and I'm saving this into a string called message, and then I want to print the message, whatever I'm inputting. So that's how we use the input utility. So when I run this, it will show enter a number to print it, and you will see a prompt like this. Let's say you enter 20 and press enter, it will print 20. So that's how you can actually use a prompt instead of using a very explicit block of code. And also you have to understand that although I have entered a number, it's not an integer, because when I'm typing a type of the message, the variable type is string. So whatever you are inputting in an input message or a prompt, it will be stored as a string, whether it be a number or a character, something like that. Now, another important concept is division versus mod in Python. When you are using the division operator here, 2 divided by 2, if you run it, you will get 1. But if you get a modulus operator, it will see whether it is divisible completely by this number. So when you use 2 mod 2, you will get 0 because there is no remainder. So that's one good way to check whether a number is divisible by another number. For example, if you use 7 mod 3, you will get 1, because after you divide it by 3, you will get a remainder of 1. So 1 is to get the resultant, the division operator, and another, the modulus operator, is to get the remainder. Now let's get introduced to the while loop. While loop is kind of like a for loop, but it will continue to run unless your given number becomes false. So by default, your given condition, your given condition or situation is true, and it will continue to run, and it will continue to go through that loop unless it reaches the end. So let's say you have defined a variable called my number, the initial value of which is 10. Now you are running a while loop. While my number is smaller than 20, it will print my number. So at first it will print 10, and then it will increase the value of the number, my number plus 1, and then it will check again whether it's smaller than 20. So then it will print 11, and then it will print 11, and then it will check again whether it's smaller than 20. So you can understand that this loop will run until it reaches 19 or 20. When it reaches 20, it will see that my number is no longer less than 20, so it will stop there. So when I run it, it will print a series of number from 10 to 19. So that's the utility of a while loop, and the difference between a while loop and for loop is this. Now you can also use a prompt like a user input to use in a while loop. Let's say you want to keep entering a number unless you press Q or quit. So and you are saving continuously the message of the user in this empty string. Now, while the message not equal to this operator is this operator means not equal to something like that. So let's say if your message is not Q, so unless you press the button Q, it will continue to keep this prompt, it will continue to keep your input into the message string, and it will print that message. For example, if I run this loop, it's printing keep entering a number, press Q to quit, and there's a prompt. So I'm entering 10. It will ask again, I'm entering 20. It will ask again, I'm entering 30. It will ask again, let's say I'm pressing Q, and it will end. So this while loop will continue to run unless I press Q. So that's how you can use a user prompt to run a while loop. Let's say, and now let's introduce to another concept, break. So sometimes you want to get out of the loop if something happens. Let's say you are running a while loop, and when someone is running a while loop or doing something or using a user prompt, you want to keep printing something, and when someone presses Q or quit, you want to break out of the loop. So that's what happens. The break keyword actually keeps you out of the loop. So let's say while true. While true means any statement that starts with while true means by default it's true, and it will keep running forever unless you break out of the loop manually. So let's say you start with a prompt, I want to buy something. Let's say you want to create a grocery list, and while true, you will keep printing the items in the grocery list. So you are collecting the grocery into input prompt. And if grocery is equal to Q, when making the list, if someone prints Q, then it will break out of the loop and your list will end. Otherwise, it will keep printing the grocery. Let's say what happens when I run this. It says, I want to buy, let's say, apple, and it's showing another prompt. Let's say banana, and it's showing another, let's say detergent, and it's showing another, and I'm pressing Q. And it's ending the loop here. So that's how we can use a user prompt in a while loop and use break loop to get out of the loop. It's getting out of the loop because I have actually printed Q here. Now let's use another concept, continue. It will get out of the loop, but it will take you, it will allow you to run the rest of the portion of the block. For example, while we were in break, when you used break, we have gone out of the loop and it ended. But in continue, it will not end. Rather, it will allow you to use the rest of the block of the code. So let's say we have started my number, and while my number is equal to 10, it will continue to increase my number. But inside I have used the if conditional. If my number mod 2 equal to 0, that is, if it's an even number, it will continue. That is, it will get out of the loop and it will start again, and it will see whether my number is equal to 10. And if it is not my number equal to 2, then it will print my number. So you can actually understand that it will print only the odd numbers which are smaller than 10. So what is happening here, that it's checking whether my number is smaller than 10, and then it has increased the value by 1. So when it is 1, it's printing my number. But if it is equal to, but if it is an even number, then it's continuing. And then it's going to the beginning of the loop, and it's increasing the number again and coming back here. And then when the value is equal to 3, it's no longer going through the continuing loop, rather it's printing the number itself. So that's how we can use while loop, break, and continue, 3 very important concepts in Python coding. The next lecture will be another very important one, functions. I will see you there. Thanks. Hello and welcome to the 9th lecture of Python concepts, that is functions, one very fundamental part of programming. And in the last class, we have learned about how to use while loop, break, and continue statements to use several functionalities effectively. Now, we want to introduce the concept of function. That is, many times we need to do the same thing, but we don't want to do this manually for different values. Let's say I have to do the same task for 100 values, or I want to test a block of code for different values, but I don't want to write a new block of code each time I want to run the code. So that's why I have to automate this function, automate this objective. And to facilitate this, I can define a function. I can write a generalized chunk of code, which can be called and which can be executed for different values, and it will be behave or return a result accordingly. So this is a very simplified syntax of function. So to define a function, you have to use the keyword def, and you have to give a name to a function. It can be arbitrary, anything. And inside the parentheses, you have to pass an argument, that is the value for which you will call the function. And inside that indentation of the function, you will do something, you will return or print something, or you will do an operation, something like that. And this is how you call that function. You call with the name and you call with the specific argument. So this function, what it does is that its name is find square. I have named it arbitrarily. It wants to find the square value of a particular number. That is, it will return number times number. So if I call this function find square with the arbitrary value 20, it will return the square of 20 by multiplying it by itself. So let's say if we run it for any other value, let's say 5, it should return 25. So that's how a function actually works. You can save this block of code anywhere, and if you call this function with any number, it will just return its square. And also you can do some other words with this. For example, I use the def keyword to introduce initiate a function. I'll name it greetings, and you can pass multiple arguments. Let's say it will take 2 arguments, name and stuff. So I want to print a customized greeting for customers by taking their name, and I will ask them to take a stuff. So inside the function, what it's doing is it is printing a string, greetings plus the name that you have called with, and also take a stuff, the stuff that you have called with. For example, if I call this function with name X and stuff chocolate, it will return greetings X, take a chocolate. Or if you call it with A and cookie, it will show greetings A, take a cookie. So that's how you can automate the functionalities. And also you can use for loop or conditionals inside a function. You can actually do anything that you have learned so far inside a function. So let's say I would like to write a function to find out whether a number is even or not. So I'm defining a function called find even, and I'm calling it with a num. And inside that function, I'm running a if statement, an if statement. If the definition of even is satisfied, that is, if the modulus operator with 2 return is equal to 0, it will print even, or else it's not even, so I will print odd. So if I call this function with number 11, it will show odd. But if I test it with an even number, then it will return even. So the last example with function is that it's increased number with nums. Let's say you want to call it with a list, and you want to increase the value of each number, and you want to multiply each number by 2. And at the end, you want to return those increased numbers. So that's why what you have to do is you have to pass a list called nums, and I would like to collect the increased numbers in an empty list called new nums. So I will run a for loop inside that for I in nums, that is for each element in the list that I'm passing, it will append it to the empty string, the empty list, new nums. It will use the append utility, and inside it will store the doubled value of each element, and then at the end it will print the new values. So for example, I'm calling this function increase number with the list 2, 4, and 5. So what it will do, it will run a for loop through each element, and in this new nums, this empty list, it will collect the doubled values of each number. That is, for 2, it will collect 2 times 2, that is 4. And then in the for loop, it will go to the next element. It will collect 4 times 2, that is 8. And it will go to the next element. It will collect 5 times 2 equal to 10. So at the end, it will print the new numbers, 4, 8, and 10. It will print the new nums list. So that's how we can use a for loop inside a function. That's what I had to share about functions. In the next lecture, we will introduce the concept of object-oriented programming or classes. Thanks. Hello and welcome to the 10th lecture of Python concepts, object-oriented programming or class. So in the previous lecture, we have actually explored a very fundamental and very necessary component of programming, that is functions, and we have learned how to use functions to automate our blocks of codes and how to reduce manual portions. We have also learned how to use functions in order to use for loops and conditionals like if statements with a great efficiency. And now this particular lecture is kind of different because all of the previous lectures, if you have followed through it, those were focused on using variables and modifying their values and the functionalities according to our need. But this is kind of different because here we will be introduced to kind of real world development of programming by being introduced to objects and classes. So what are actually classes? Classes are actually behaviors, a set of behaviors that is set for objects, and objects are stuff that have different attributes, like different properties that something has. So think of a house. In a house, there's a certain blueprint that actually defines how the house is. So a class is kind of an equivalent of a blueprint. And when you make a house, those house has so many components. And those components are equivalent to objects. And each object, like a door that can open and shut, a window can open and shut, and the other components that also have their specific functionalities. So very similarly, objects also have specific functionalities, and you can actually define a class And and for each object inside it, you can actually define specific functionalities or attributes. So that's kind of a background of how to be introduced to object-oriented programming. Now let's do very simple object-oriented programming associated code so that we can get used to all the terminologies and we can understand what's going on here in object-oriented programming. So for that, let's say we want to make a class named car. So in this car, we will actually store several sets of information, like what makes are those, what models are those, and from which years models are those. And also these kind of attributes we will define. And after that, we want to see if we call or if we initiate a class with a specific attribute for an object, then what it shows for a particular model. So this is kind of a syntax for object-oriented programming. We start with the keyword class. That means that you are actually initiating a class called a car. And this also looks like how we write a function. And we start with the keyword def, and we initiate the instance of a class with 2 underscores, and then init keyword, and then another 2 underscores. That actually alerts Python that you are starting a class. And inside the arguments, you have to pass an as the first argument called self. It will always be there, and the other attributes that you want to assign to your objects. So for the self keyword, what is happening is that you are making this instance, you are making this class to the every available instances. And inside that definition block, the initiation block, you can actually define the attributes. For example, to do that, you have to actually make it under the self keyword. So you have to use self dot. So let's say you have 3 attributes: make, model, and year. So self dot make, let's say you have give it a name make, and then a model, and then year. And also what you want to do is that you want to see what happens if you call this class. And that's why you are initiating another def. When we are working inside a class, we don't call them functions anymore, we call them methods, so that they can be applied to the class objects. And then let's say you have a long name, and that for that long name, you are actually defining a string inside which you will show the year, you will show the model, and you will show the make of the car of yours, and after that you will return that long name. So what is happening is that you are actually defining your car in terms of your make, model, and year. And when you are calling the class car, that will know that you are calling your specific car with specific make, model, and year, this kind of attributes. Remember how we have defined class with objects with different attributes. So if it was a house, it will have different properties, different objects, different elements with different attributes, like several doors or windows or walls, something like that. So similarly, what is happening here for car, you are also defining different attributes of your objects. And then you have initiated your method under which you are defining all the attributes. And then you are trying to return those attributes. You are trying to see them. And then let's say you are defining my new car as an instance of your class car, under which you are defining a very specific set of attributes like Toyota, RAV4, and 2012. And when you run this, you can see actually 2012 Toyota RAV4, because you are printing my new car. Under this my new car instance, you are actually trying to get description. So this method that you have initiated, which has actually stored all the attributes. This may sound kind of hazy at first, but after you write a few blocks of code in object-oriented programming, everything will start to make sense. So let's say you want to include another value, or you want to set a value to a particular attribute. So what I have done is that is the same block of code. What modification I have made is that, let's say you want to include the odometer reading here also. So for that, you have to actually write under the self keyword, you have to pass another argument, odometer reading, and set a value for this. Let's say initially it's 0. So after that, what we have done is that we have introduced another method called read odometer, which only has the self keyword, self attribute, because we don't have to define it separately here, because we have already set the value here. And what it does is that when we invoke this method, it will print the current mileage, and it will convert the value, the 0, to a string, and then it will call it under self, and it will print the odometer reading. So what we have done is the same thing, my new car, and then we print my car description, what I have already done. And what we add is that my new car, under this instance, we are asking read odometer, this method, and when we are calling this method, it will print this self odometer reading, which is 0. Now, can we actually modify it? Yes, absolutely. That is one of the main purposes of ours, that we can modify attributes through a method. So let's say you want to update the odometer after buying a new car, you're actually running it. So what we have done is that aside from the make, model, and year, you are actually trying to update the odometer. So for that, you have, aside from the self keyword, you have to also pass the argument mileage. And let's say you want to update the mileage. And for that, you have to actually call this instance, my new car, under this method, update odometer, with this argument 500. Let's say you have run for 500 miles and you want to update it. And when you call with this particular value, what it will do is that under this my new car instance, it will invoke this method update parameter, and then it will, as it is already set for mileage, current mileage, it will print current mileage. After converting to string, it will show self.odometer reading. What is odometer reading? That is currently 500, as I'm calling with this. So that's kind of a very short introduction to object-oriented programming. By implementing those in the later videos, we'll try to make some small applets or games, or we'll try to implement for data analysis at large scale, so that all can make sense. And we will also we'll definitely implement the earlier ideas that we have learned, like functions and conditionals and the basic ideas of coding. And the last note about class is that you can also import classes to, let's say you have saved this block of code in a Python file, .py file, and you can call it to another code. Let's say from, let's say you have saved it in the name of car.py, then you can actually import it from car, import car, and then continue to work on these. Every module or instances will be available at your disposal, so that you can actually separate your chunks of codes to increase your efficiency. So later in our projects, it will become more obvious, and we will see how to divide our chunk of codes to make our writing of code very clean and sleek. And in the next class, we'll see how to deal with files. Until then, happy coding. Hello and welcome to the 11th lecture of this playlist, Files. In the previous lecture, we have introduced the concept of object-oriented programming, that is class, and we have shown how to use our earlier concepts in terms of object-oriented programming and how to use them. So far in the previous 10 lectures, we have learned how to deal with data and how to deal with variables. But we have mainly worked with locally produced data. We have manually created a list or a collection of numbers and performed operations on them. But in real life, you generally work with files saved on. In real life, you work with data saved on a file. So it is very important to know how to read a file saved in a directory and how to access the data or how to write data in a file. So in this short lecture, we'll introduce to that so that you can access real life data and then read or write them or modify them according to your need. So the first portion of this lecture is reading a file in a directory. For that, first you have to define your file path. So for example, in my local machine, this is the file path, and I have saved a file, myfile.txt, where I have just 3 lines of data, 10, 20, and 33 numbers. And what you have to do is that with the with keyword, you have to open your file path, and then you have to read your file as a file object. And then you can give it a name, contents, whatever you are reading. And then you can print the contents to see them on the screen. You can see that when I run this code, it's showing just 3 numbers because that's what is saved in that file, myfile.txt. And that's how you can read what is already saved in your local machine. What if you want to write something? Then the task is kind of similar. You have to just define your file path, and then with open file name, and you have to use W, that is, you want to write in a file, and then you have to use .write method. Let's say you want to you want to write I love programming in your text, myfile2.txt. Then you can see that there's a file where this code is actually written, I love programming. So that's how you can generate data or store data, read and write these kind of basic functions you can do. There are a lot you can do to access your data and modify them. So that's pretty much I had to share how to read and write data in Python. So and also we effectively finish our basic understanding of Python concepts. The next part is to implement what you have learned. You have learned how to deal with data, how to list of numbers and variables, how to use conditionals, how to use loopings, and how to use object-oriented programming. To get very good at programming, you have to actually implement this data. You have to go beyond your theoretical understanding and dealing with small chunks of code. Rather, you should try to make something practical, like a small app or a small game. However small or simplified it is, it will give you a real world feel of programming. So I would suggest you to first do some drills on practical problems, like interview problems, which are discussed in my other playlist, Python drills. And another playlist you can explore is Python projects, where I will discuss how to make real life projects by using Python, like a tic-tac-toe game, or something simplified about those, a small applet or data analysis tool. So I hope that I hope that these videos will be useful for you and you will be able to use them. And also happy Python drills and Python projects. I wish you the very best.